Welcome back, fellow factorials. In today's video, we're going to talk about one of the most fascinating and mysterious topics in the universe: black holes. What are black holes? How do they form? What happens inside them? And what secrets do they hide? These are some of the questions that scientists have been trying to answer for decades, but there are still many mysteries and challenges that remain unsolved. In this video, I'm going to share with you some of the most interesting facts and discoveries about black holes, and also some of the questions that scientists are working on to unravel their secrets. But before we get into that, I'd love to hear your thoughts and opinions on black holes. So, what are black holes? Well, according to Einstein's theory of general relativity, black holes are regions of spacetime where gravity is so strong that nothing, not even light, can escape. They are usually formed when massive stars collapse at the end of their life cycle, creating a point of infinite density and zero volume, called a singularity. The boundary of a black hole, beyond which nothing can escape, is called the event horizon. The size of the event horizon depends on the mass of the black hole. For example, a black hole with the mass of the Sun would have an event horizon of about 3 kilometers in radius, while a black hole with the mass of the Earth would have an event horizon of about 9 millimeters in radius. Black holes can vary in size and mass, from microscopic to supermassive. The smallest black holes are called primordial black holes, and they are believed to have formed in the early stages of the universe due to fluctuations in the density of matter. They could have masses ranging from a fraction of a gram to several thousand tons. The most common black holes are called stellar black holes, and they are formed by the collapse of massive stars. They typically have masses of a few times that of the Sun and can be found throughout the galaxy. The largest black holes are called supermassive black holes, and they are found at the centers of most galaxies, including our own Milky Way. They have masses of millions or billions of times that of the Sun and can have event horizons of millions of kilometers in diameter. But how do we know that black holes exist if we can't see them? Well, we can infer their presence and properties by their effects on the surrounding matter and light. For example, we can detect the gravitational waves produced by colliding black holes, which are ripples in the fabric of space-time that travel at the speed of light. In 2015, the LIGO and Virgo observatories made the first direct detection of gravitational waves from a pair of merging black holes, opening a new window to the universe. We can also observe the X-rays emitted by the hot gas in the accretion disk around a black hole, which is a swirling ring of matter that is being pulled in by the black hole's gravity. The X-rays are produced by the friction and heating of the gas as it spirals inward. The Chandra X-ray Observatory and other telescopes have detected many sources of X-rays that are likely to be black holes. But what we really want to see is the event horizon of a black hole, which is the ultimate boundary of no return. The Event Horizon Telescope is a project that aims to capture the first image of the event horizon of a supermassive black hole using a network of radio telescopes around the world. In 2019, the EHT team released the first ever image of the shadow of a black hole, which is the dark region in the center of a bright ring of light corresponding to the event horizon. The black hole in the image is located at the center of a galaxy called M87 and has a mass of about 6.5 billion times that of the Sun. But what happens inside a black hole? Well, that's where things get really weird and mysterious. According to general relativity, the singularity at the center of a black hole is a point of infinite density and zero volume, where the laws of physics break down. However, this is likely an incomplete description, and we need a theory that can unify quantum mechanics and gravity to fully understand the nature of singularities. One of the most intriguing questions is whether black holes have a structure or a surface inside the event horizon, or whether they are just empty space. Some theoretical models suggest that black holes could have a firewall, a ring of high-energy particles that would incinerate anything that falls in, or a fuzzball, a tangled web of quantum strings that would stretch and tear apart anything that comes near. Another question is whether black holes have an interior or an exit, or whether they are just one-way trips. Some scientists have speculated that black holes could be wormholes, shortcuts in space-time that could connect distant regions of the universe, or even different universes. However, there is no evidence or observation to support this idea, and it is likely that any wormhole would be unstable and collapse before anything could pass through. One of the most puzzling questions is whether black holes destroy information or whether they preserve it. Information is the measure of the order or complexity of a system, and it is a fundamental quantity in physics. According to quantum mechanics, information cannot be created or destroyed, only transformed. However, according to general relativity, anything that falls into a black hole is lost forever, and the only information that remains outside is the mass, charge, and spin of the black hole. This is known as the Hair Theorem, and it implies that black holes erase information, creating a paradox. This paradox has led to many debates and proposals among physicists, such as the holographic principle, which states that the information of a system is encoded on its boundary, or the quantum Hare hypothesis, which states that black holes have more properties than mass, charge, and spin, or the black hole complementarity principle, which states that information is both reflected and absorbed by black holes, depending on the observer's perspective. These are some of the questions that scientists are working on to unravel the secrets of black holes. But there is still so much more to learn and discover about these amazing and mysterious objects. Black holes are not only fascinating but also important for our understanding of the universe, as they can reveal the nature of space-time, gravity, and quantum physics. And now, I want to hear from you. What do you think about black holes? Do you have any questions or comments? Let me know in the comments section below. I'll try to answer as many as I can. I hope you enjoyed this video and learned something new about black holes. If you did, please give it a thumbs up and share it with your friends. And don't forget to subscribe to my channel and hit the bell icon so you don't miss any of my future videos. Thank you for watching, and I'll see you in the next video. Bye.